All right, Alan, a member of our carnivore certification program, recently certified as a nutrition and fitness coach, or just a nutrition coach at the moment?
Just a nutrition coach at the moment. Just following the all the content that's being uploaded to the fitness group as
Right.
and when it gets put
Yeah.
up and following it. So yeah, that's where I'm
Yeah.
at the moment.
Good. You're seeking the fitness certification as well, correct?
Yeah. It's
Okay.
something that I'm interested in, and no, I think it's something that's gonna, yeah, something that you're interested in. It's always going to add a lot of extra knowledge that you thought you may have had, but may not, and
Hmm.
it's going to fill in the gaps there, isn't it? So
Right.
yeah.
Yeah. How have you enjoyed the program thus far? You know, what's actually taught, how it's taught, the interaction involved in there with the community, if you don't mind me asking.
Yeah, the interaction with the community is really good. It's good to know that everyone's got each other's backs, everyone's asking questions, and it's good that yeah, you know that everyone, yeah, and but people ask questions that you might think, yeah, that's something maybe I was thinking,
Hmm.
and without even knowing it yourself. And it's
Yeah.
always good. Yeah, it's good to um, just see what other people are, their experiences are, and everything. It's yeah, no, it's yeah,
Yeah, I've noticed that now that I've been working with people and receiving questions about, like, for example, me building my new course and everything. I've realized
yeah,
that there's a lot of questions that are asked that I almost, you know, I almost get upset with myself for not having those questions before and having asked them before. A lot of them I've
yeah,
asked those questions myself, and then I'm like, okay, well, I already know the answer to that. I thought about that like a year or two ago or something. And some of them I'll see them though, and I'll go, oh yeah, no, that's actually a good question. Let me think about that. So the community aspect is one of the most important and often neglected aspects of this.
yeah,
I think that it's arguably one of them. It's the most critical part because,
definitely,
what can you do with information of the highest quality? um you can do a bit with it, but without actually being able to communicate that knowledge with other people and to
mm,
hear other people's questions about it and the way that they're
yeah,
thinking about the concepts and their perspectives, like, you're not getting nearly as much of a benefit as you are with other programs that, yes, might have good information, but where's the community aspect of it? Once you're done, it's like, okay, here's your certificate, have
mm,
fun,
yeah,
like. So I
yeah,
think, yeah, I comment on that quite a bit. So I'm glad to see that someone else, I'm not alone in that respect of actually uh, enjoying that aspect of it and appreciating it for what it is offering people and what it truly is. So
mm,
awesome. Well, with that being said, you've got some questions for me regarding some of that material, particularly regarding uncoupled versus coupled mitochondria, what that even means in the first place, and
yeah,
also, the Randle cycle as well. So, two of some of my favorite concepts. So,
yeah.
can't wait.
Cool.
Yeah.
Yeah. So yeah, the uncoupled mitochondria is it's something which on the surface it seems like something which is it's kind of easy to sort of grasp what it is, as in like the mitochondria is not in a place where it may want to be or should be, but it seems necessary at the same time. Does that make sense?
Yes.
And
Yes. So
those
basically doing something given the circumstances that they may not want to do if they were conscious or something like that.
that's right, yeah.
Yeah,
So
yeah, yeah.
sort of those two almost opposites overlapping
Yeah.
and then trying to make sense of it to unwrap it as well. It's yeah, it might take a bit of like, just explaining it in, plain English, and then
Right.
that might help to make more sense of how uncoupled mitochondria then is associated with, like, good mitochondrial health.
Mm-hmm. Yeah. Yeah. So with respect to uncoupled versus coupled mitochondria, there is a way that it is taught, and it's not exactly correct. And it's only because I'm not saying it's with any malice or anything. I had a discussion with you a few weeks ago about this. A lot of it has nothing to do with malice. It just has to do with the fact that the models are just not like in practice they don't result in any errors too much, but the
Yeah.
actual fundamental logic behind it is still flawed. This has to do with a flawed understanding of the way that the mitochondria create ATP in the first place. So you may have heard of, the electron transport chain, oxidative phosphorylation and all that. The process of chemiosmosis, the way that the mitochondria will use, electrons from substrates and create ATP. Well, I'll tell you the traditional way that uncoupled versus coupled mitochondria is taught, and then I'll go into the actual reality of it.
Sure. Okay.
Because it relates directly to this. So coupled mitochondria are mitochondria that operate sort of at a 1-to-1 ratio. So the amount of ATP they're creating is directly coupled to the amount of energy, quote unquote, amount of substrate they're sort of receiving. So they're creating 1 unit of ATP per the exact amount of substrate required to create that ATP. So they're directly coupled 1-to-1.
Okay.
Uncoupled mitochondria is the process whereby the mitochondria become inefficient or wasteful,
Yeah.
which is where they absorb, so take up a lot more substrate than is actually required to create a unit of ATP that is required at that moment. So that makes them release a lot more heat, because if you think of two things reacting together, there's a lot of heat that can be released, and all that heat is it's a sign of chemical inefficiency. So it's not actually converting mass to mass. That there's some mass that's actually being released as energy in the form of heat. So that's why they release a lot more heat. The idea as to like what the exact reasons as to why this happens are, or rather what is causing the mitochondria, what is really going on when they're taking up more substrate than is required to make ATP. Okay, this is the way it's taught. Traditionally, in mitochondria, typically, they take up electrons from sort of hydride ions from NADH and FADH2, and they travel along the electron transport chain via multiple different complexes.
Okay.
Again, this is how this is taught. The electrons go through the complexes, and after they sort of enter through each complex, most of those complexes are involved in pumping protons from the matrix into the intermembrane space of the mitochondria. So there's a proton flux, so to speak, between matrix to intermembrane space, and that creates a proton gradient. So that then you get a differing of concentrations, and what ends up happening is those electrons, when they travel through the electron transport chain, they will of course, their main purpose is to actually cause the proton pumping, because they cause a bunch of energy to build up in each complex.
Yeah.
And the electron will then go on to oxygen, and this creates water. So that's one of the main reasons you breathe out water vapor. So the oxygen is your final electron acceptor in the electron transport chain. But the main way that this creates ATP is through that proton gradient. You get a buildup of protons in the intermembrane space, and then according to its concentration gradient, things want to flow from high concentration to low concentration. They flow through a protein called ATP synthase. And it causes that motor to spin, and that creates chemical potential energy, and that chemical potential energy is encapsulated in the form of ADP and PI to form ATP on the sort of alpha and beta subunits on ATP synthase proteins. Okay, so basically electrons are flowing in, they're creating a bunch of energy that causes protons to flow into the intermembrane space, and then they go and flow back to their normal concentration gradient, like according to their concentration gradient, and it's just a cycle. Protons are pumped in here, high concentration, low concentration now, they flow back in, and that's the energy being produced. The energy that's being used to pump those protons is created through those electrons flowing through that chain. Okay, that's the traditional way of teaching it. And so therefore, from that traditional teaching method, we can sort of explain via that teaching method what uncoupled mitochondria are. Okay. Uncoupled mitochondria, according to that method, or that sort of model is really what we should say, is the process by which, according to certain circumstances, typically times of low insulin, times of high fatty acid oxidation, there will be a process that involves a sort of pore opening up in the matrix of mitochondria. Okay. And this pore is completely sort of uncoupled from the ATP synthase motor. What does that mean? That means that whenever you pump protons into the intermembrane space, typically they all flow through ATP synthase. There's only one funnel. And so all of them have to go through ATP synthase. And as they go through ATP synthase, they cause the motor to spin, and that creates the energy to create ATP.
Right.
Well, now imagine that you've opened up another funnel. And this funnel, whenever protons flow through it, they are not involved in producing ATP. Like they don't actually, there's no motor that spins. They just flow through back to the matrix. Well, now you've got two funnels where protons are flowing through. One of them is not involved in creating ATP and the other is. So you've actually diluted how much is flowing through ATP synthase. So you're creating less energy per proton that's pumped into the intramembrane space.
Right. So you're almost creating heat rather than energy.
Yes, exactly.
Got it.
Exactly.
Yeah.
Exactly. So those are the traditional models. And the last detail that I'll add is that this uncoupled phenomenon in mitochondria, typically, it only occurs in fat cells over long periods of time of fatty acid oxidation, because if it occurred in other cells, that would be disastrous, because most cells actually do need to be coupled. They cannot be inefficient like that. Your fat cells can afford to do that because you'll create, beige or brown fat, brown adipose tissue, which is actually involved in creating heat to warm you up through non-shivering thermogenesis, right? The muscles will do shivering thermogenesis, but other cells cannot do that because you'll lose a bunch of muscle, you'll lose a bunch of, it's disastrous. In fact, there was a drug that actually did that in the past, in the mid-1900s, called 2,4-dinitrophenol, actually. And it did exactly that. It was known as like a miraculous weight loss drug. And it actually was. People were losing massive amounts of weight.
Yeah.
They were also dying left and right because eventually they were becoming extremely inefficient systems. They weren't holding on to anything.
Sure.
So that's all of that covered. But why do I keep saying according to the traditional model? That is because the reality, whether biochemists that may be listening to this, they don't want to admit, but it is true. We have no actual idea how the mitochondria are creating ATP.
Right.
That is a model called the chemiosmosis model. It is also called, more correctly, the chemiosmotic theory, because we have no idea if that's actually what's going on. What we do know for a fact is that, yes, as ATP is created, there is a fluctuation in pH between the intramembrane space and the matrix.
Okay.
There is a fluctuation of pH, which does correspond, the pH literally of a solution is the concentration of protons in a solution. So what they are saying is that protons are coming from the matrix and going into the intramembrane space and vice versa, according to concentration gradients, right?
Right, okay.
The problem with that theory is that is not physically possible and cannot be true, because protons are dependent variables. They're not independent variables. They can't go from, you can't change the concentration of H plus protons in a solution by adding or removing protons from it.
Sure, yeah.
That is why the model is necessarily wrong. It's necessarily wrong. Yes, we do see changes in pH between those two fluids, but it cannot be due to protons being pumped. We have no clue how it's actually happening. That model in practice can work conceptually to try and understand, okay, well, we can maybe formulate a drug that does this and has this effect on mitochondria, whatever. We do have those drugs called proton pump inhibitors for stomach acid regulation, right?
Okay, right, yes.
And they do have their intended effect, but their mechanism is not the actual mechanism, because that is physically impossible. That would actually disobey the laws of physics.
Yeah, so that'd be something like if you've got indigestion, that sort of thing.
Yeah. So or really acid reflux is typically So proton pump inhibitors, the idea behind those is effectively the same phenomenon where they try and inhibit proton pumping, because the philosophy is, well, these certain cells in your stomach are involved in pumping H plus protons into the solution. Yeah. And that's what acidifies the solution, because hydrogen will form to Cl minus chloride to form hydrochloric acid. And then that's how you get a bunch of stomach acid in your, and if you have too much, that'll cause, a bunch of pain and, all eventually Barrett's esophagus if it's extremely bad.
Yeah.
The problem with that philosophy, once again, though, is believing that H plus is an independent variable, and that's how acid or the fluid in your stomach is made acidic. That's not how that works. Actually, what it does is it pumps chloride ions into the solution, which causes the water molecules in your stomach fluid, H2O, to dissociate into H3O plus and OH minus. H3O plus basically being H plus. They just don't exist on their own as H plus in a solution. That's where you get the hydrochloric acid phenomenon from. It's acidifying the solution by adding ions in.
Okay.
It's not adding H plus in. The H plus forms spontaneously from water dissociating to negate the charge. It's the law of electroneutrality. That's what's actually going on. Right. Their philosophy is just, well, the protons are being pumped from a cell into another solution. That is a physical impossibility. It cannot be true. So the reason this ties into uncoupled versus coupled mitochondria, you may already see, which is, well, the idea is that, well, you have another pore that opens up and it causes more protons to flow through.
Yeah.
Sort of according to their concentration gradient.
Okay.
We do those pores exist, but it's not that they're just flowing in according to their concentration, high to low concentration. There's something else going on that we don't really know. Sure. What we do know is that there's chemical inefficiency. There's a bunch of heat being released. So there you go. But I can't say definitively what the actual mechanism is because no one really knows.
Yeah, so this is like a half. We're sort of like halfway there almost. Like we know what it could be doing, or there's a part of the story there that we know something's going on, but it's a mystery as to what that something is.
Yep. I mean, people fail. A lot of times they will not remember that something was considered a theory whenever they were taught it, because it makes. If the story makes sense, it must be true. That's how humans kind of think. Because, of course, if a story is true, it should make sense. But that doesn't mean that if a story does make sense, that it must be true. The backwards doesn't, So the chemiosmosis theory is called a theory for that reason, because we have actually never, ever, ever observed protons actually being pumped via one fluid pool to another. That has never been observed. What has been observed is that there is pH fluctuation between those two solutions. And from that, people have hypothesized, well, then that must mean that the protons are actually going from this space to this space.
Yeah.
It's not, it is a physical impossibility, though. So,
right.
Yeah.
Cool. Right. Okay. No, that's clear. Yeah, that's cleared it up a bit. And it's, because you explained it there in the sort of way that you probably wouldn't even be able to write down in something like a course,
Yeah.
Well, it would be quite difficult, to go into that much depth as well. And it's, but no, that's helped a lot. With the concept of uncoupled mitochondria. And that's good.
Well, that's good. What I will say is, if you so we're recording this, so I can send this to you afterwards as well, so that you can review what I've said as well. But if there's anything else that needs further clearing up, I think it would be easier to understand if, and I'm not saying you don't know this, but if you don't already know this, the structure of mitochondria, if you just look that up too, just to look and see where the intramembrane space is, where the matrix is, the inner and then the outer layer of the mitochondria, you can get a better understanding of the whole concentration gradient model of where, you get a buildup of protons in the intramembrane space, therefore less in the matrix, and then they flow through, and it's just this cycle. Because as much as that model is necessarily false, it doesn't change the fact that the model is actually I think is actually a good way to introduce the concept still. Yeah. Because you will get an idea, okay, well, that sort of makes sense, but then add the final detail at the end, go, okay, by the way, this isn't technically happening, but it's a way of conceptualizing how the metabolism works in the body for practical application, if that makes sense.
Yeah.
So because even that pH model that I just gave you of acid-base balance of like, okay, well, protons are not independent variables. That is a Stewart model of acid-base balance, and actually the proposed reason as to why the model works is itself also false. So we actually have no idea what's really
No,
going on. Like
no.
it's a matter of what happens on the macro level, and does this model work to on the macro level? If it does, well, then that's going to be our best inference within reason, and that's
Mm,
what we go for. And
sure.
so that Stewart model is just the next step. It's a further level that is more correct than the other one, and I mean, it is still correct. It's just the purported reason as to why the model is correct is wrong too. So
Yeah.
that's also interesting. Yeah.
Cool. Okay. So the other area I think is the Randle cycle that
Hmm.
is also a favorite of yours.
Yes, it is indeed.
Yeah.
Yeah.
The that diagram that I think you and Bart K on a
Hmm.
video, it was months ago now, like you both went through it. And yeah, it I think to anyone who looks at it first, it's just going to blow your mind, and like the names of the different like the reactions, and this turns
Uh-huh.
into this, into this, into this, and then you've got like fats on one end, the carbs on the other, and then they meet, and it's I think basically, long story short, it's if you have a mix of too much of a mix of both, you're in a bit of trouble. But if you
Yeah.
both, yeah, it's
Yeah.
I think yeah, it's just getting into more of the scientific side of things, isn't it?
Hmm.
Where the
Yeah. Well, yeah. So I was just gonna say. I mean, are you looking for specific clarification on the broad concept of the Randle cycle, or specific parts of it that you didn't understand? Because I can go into both. I mean, it's fine.
yeah, so I guess it's when so on the bottom bit where you've got I think before it just enters the mitochondria,
Hmm.
and they when they both meet, and it's that bit I think where you've kind of got both going on, and the reaction that is going on there that we might be sort of looking to go away from. If that makes sense. I think that might be a good place to start.
Yeah. So you covered it pretty. I mean, you covered the general concept, which is that a mix of fatty acids and glucose in a high enough concentration on both ends is
Yeah.
going to be problematic, inferred
Mm.
from this mechanism. The mechanism is just it's a cross inhibition between fatty acids and glucose. But what does that really mean? What it means is that if a cell is oxidizing one of those substrates, and the other one comes along and goes, "Hey, I'm here now. Let me get oxidized." The
Yeah.
cell is going to have chemical pressures to prevent that from happening. It takes some effort to get the other pathway that oxidizes the other substrate to actually get going. Um, Insulin is one of the primary regulators of this, but it's not the only one. It's not sort of a dictator of fuel use. Um, it doesn't dictate what is used according to its concentration, because there's also back pressures from the cell that also say, hey, you know, not yet, so to speak.
Yeah.
The reasoning as to why it happens is quite interesting. I mean, it seems that if they were, there are ways for the mitochondria to oxidize all substrates at once, and in fact, it does happen
Yeah.
under times of extreme oxygen deprivation, um, or times of like really high intensity exercise.
Okay.
So anytime that there's a huge energy demand, the body will do that. But you must ask yourself at that point, well, why is it only under extremely harsh conditions? I mean, that might be an inference in and of
Yeah.
itself. Like,
Yeah.
is there a drawback to doing it? Is it a trade off? The theory is that if they are if slash when they're oxidizing both substrates at the same time, you will get sort of this increase in reactive oxygen species, ROS production, because there's something that happens in the proton motive force electron transport chain situation where you get actually like the sort of backflow of electrons into previous complexes, and it causes more it causes more reactive oxygen species. So it causes more H2O2, hydrogen peroxide production. It causes more superoxide production. And that's a bad thing because, as we know, they're very highly reactive, spontaneous, volatile, and that's going to damage tissues, including your DNA.
Yeah, yeah.
That's the theory. I don't know if it's ever been actually analyzed on that granular of a level to prove that. So I am going to just to be safe, because it could be false when I say that it's a theory and hasn't been proven. It could very well have been proven. I haven't seen it yet. That's the theory that I've heard. It
Yeah.
seems, though, that even if that's not the case, the main reason why, the other main reason that I can think of as to why this would happen is precisely for fat gain. And the reason I say that is because if you've got a lot of glucose well, let's say that you're oxidizing lots of fat, and then you consume a huge bolus of glucose. Well, the chemical pressure, the I to G ratio, the sort of overarching chemical metabolic regulators, again, not dictators, but they have the most strong influence over anything else, generally, that changes highly in favor of glucose oxidation or pyruvate oxidation.
Okay.
And so the pathway will shift to glucose or pyruvate oxidation. But what happens to that fat? Well, it pools in the cell. And what happens with that fat that pools in the cell? Well, it's used to synthesize triglycerides, which are fats that are necessarily to be stored upon creation. They can be stored locally, created locally and stored locally at the level of muscles, for example, and also the liver and other tissues, but also fat cells themselves. So that also is, that's one of the primary reasons that the Randle cycle exists, that it tells you that whenever you're eating a mixed meal and you're actually favoring, you get lots of pyruvate oxidation, that fat will pool in that cell and it will be used to synthesize triglycerides, so stored fat. And I mean, there you go. That's the biggest problem there, and the biggest sort of, what do you call it? The biggest inference or implication there.
Implication. Yeah.
So in terms of what happens at the bottom of the graph, like how these actually regulate themselves, it's been a while since I've looked at those graphics, but I can remember what was going on. So on the left side, you've got the glycolytic pathway, and you'll see at the bottom, you see pyruvate going into trying to go and enter the PDH complex, pyruvate dehydrogenase. You see that on the bottom left, it's PDH, but it shows that it's inhibited. You've got that little T there. You've got an inhibition there if fatty acids are producing lots of acetyl-CoA and producing lots of ATP.
Okay.
Because acetyl-CoA itself, fats themselves create lots of acetyl-CoA, but acetyl-CoA itself actually inhibits the pyruvate dehydrogenase complex. So if you have a lot of acetyl-CoA being produced by fats, that's going to inhibit pyruvate dehydrogenase. It's going to cause, if the other pathways at the top, or the other, what do you call them, reactions at the top, were not inhibited themselves, that would cause a lot of lactate buildup. And so you get a lot of or what's considered lactic acid.
Lactic acid, yeah.
Right. You get a lot of lactate buildup. But fortunately, it also inhibits the pathway at the first two steps as well. So you've got, actually, there's 3 steps before even the PDH is inhibited that are inhibited as well. So you've got GLUT4 being inhibited. So the translocation of GLUT4 to the membrane to even take up glucose, that's inhibited as well.
Yeah.
As well as, and that's by citrate, as well as the reaction that converts, it's PFK1. So phosphofructokinase 1 that creates fructose 1,6 bisphosphate from fructose 6-phosphate. That one's inhibited as well. So and then the very, very last one, which is pyruvate kinase, the enzyme that actually creates pyruvate in the first place. You've got the inhibition happening on 3 different parts of that pathway, as well as in the mitochondria if fats are being oxidized. Because, well, why would we, if we're getting adequate energy from fat, why would we take it up from a bunch of glucose? Especially considering that if that glucose sits in there, but as we're like oxidizing a fat before it can get in, it's gonna harm our tissues, because glucose in even small concentrations will destroy lipid rafts. It'll destroy your cell membranes. It'll mutate your DNA. And in a high enough concentration, but still low, it'll kill a cell like indefinitely, immediately. So
Mm.
that's another reason the mechanism exists. So if fat's being oxidized regularly, well, then glucose is going to be inhibited because it damages cells. If glucose is being oxidized readily and you dump a bunch of fat in, well, we're going to continue oxidizing the glucose because it's toxic in the bloodstream as well. But
Yeah, yeah.
also, it's favorable evolutionarily to convert a lot of that fat into stored fat. So, yeah, I mean, isn't it interesting that fat can actually pool in the cell? So in this graphic, you'll actually see long chain fats, long chain fatty acids, LCFA. They're not
Yeah.
inhibited from entering the cell. They're inhibited from entering the mitochondria.
Mm.
They can sit in the cell for however long they want to because they don't
Well,
damage the cell.
yeah, that's right. Yeah.
Glucose, you'll see that the transporter is actually inhibited, as well as many other steps throughout that pathway. Granted, that's because most of the steps in glucose metabolism occur in the cytosol, um, as opposed to fat, which is mostly in the mitochondria. So there's going to be more steps that are inhibited on the glucose end than the fat end naturally, but still, it goes to show that glucose actually is inhibited from entering the cell, which I think is an implication on its own. Um,
Yeah.
so anyway,
Yeah.
um,
I think that was a good. It was Dr. Abs that he came up with this example of like how glucose cells act and how long chain fatty acids act
uh-huh.
by just imagining like you're in like a doctor's office waiting to be seen, and like you've got the you got fat just sat there minding its own business, just doing its thing, just not making a sound, and then the glucose is like the screamy little kids just running around and not knowing what to do. And I think
Uh-huh.
it's a good analogy as to
I
like
haven't
how they both act.
Yeah, I haven't heard him make that analogy, but it does work because yes, exactly. Then you would want to prevent them from being in the doctor's office unless absolutely necessary. So there
Exactly.
you go.
Yeah.
Um, Yeah. It is important to note, and I've said this before, that if we're going to be extremely logically consistent, that alone doesn't mean that you shouldn't consume glucose, for example. That just means that
Yeah.
if this is the argument made by vegans, by the way, they'll say, well, that doesn't mean that
Yeah.
glucose shouldn't be consumed. It means that if you're consuming fat, you're going to prevent the cell from you're going to actually cause glucose to do the damage that it has the chemical propensity to do if it stays in isolation for too long without actually being acted upon, which is
Yeah.
technically true. We have other compounds in the body that do that as well. You wouldn't say, for example, that since a certain cancer cell can use fat, for example, which I mean, it's very rare that this even happens. It's in very
Yeah.
select instances. That therefore that means that you shouldn't be consuming fat. It means no. What it means is that you've now gotten cancer, so your body's operating differently. Like it's just
Yeah.
it doesn't mean that. But what it does mean, like just from that logic alone, what it does mean is that yes, fatty acids are less chemically reactive than glucose, and therefore the body has mechanisms to hedge against the glycation damage that will be incurred from glucose if it sits in a cell for too long, which is like longer than a millionth of a second, because that's how long it takes for a reaction to occur in the first place. So if it can't go through this certain pathway, it'll immediately find something else to bind onto. Like there is a percentage of glucose that exists in its reactive form that will even sometimes before it enters a cell, it'll just I mean it's usually your red blood cells that get acted upon, which is why you have an HbA1c value above 0% in the first place.
Yeah. Yeah.
So, yeah.
Cool.
Yeah.
Yeah. What was the other thing? Oh yeah, the where people look to want when they want to like sort of overcome a plateau. You get these examples where someone says, take someone who wants to, achieve fat loss, and they said like, I've done everything that has worked to date, and you try and pick out, what could it be that they're not doing right, or
Uh-huh.
or how they could change it up, if that makes sense.
Hmm.
Um, how could such a scenario like be? How could an answer be come to in that sort of example where would it be like they just need like a complete reset in like their approach, or would it be that maybe I guess the protein to fat ratio might need changing up? Like what kind of things would be a good way of kind of making their progress like kick on again?
Yeah, so in regards to that question, it's going to be highly dependent on people's individual circumstances. I have witnessed people. So I'm not a coach myself, and I don't take on any clients or anything like that. But I have heard of people's stories, and I get told them through email a lot.
Yeah,
And there are a lot of people that seem to have had, and definitely do have. I think it's no doubt in my mind that they have extreme amounts of damage that they've done in the
yeah,
past that have influenced how a genotypically appropriate diet will
mm,
actually affect them. It may actually appear to affect them negatively, and there's many reasons as to why this is the case. So a lot of people will immediately just jump to, like, I did a video a while back on, for example, like gout and how people can. There's plenty of people that have cured their gout completely on carnivore, which is
yeah,
completely contrary to what you're told about meat and all that. And then
yeah.
there's yeah, and then there's plenty of people that will have gout flares when going carnivore.
That's weird,
Um,
isn't it? Yeah,
right. And I made a video on like some mechanisms that could be at play there if they have to do with, uric acid, urate concentrations and all that. But
mm,
the main point in there actually was you have to be really careful with immediately saying something is the fault of something else, like cause and effect. I mean, it's one of my main points on my videos because
yeah, yeah,
is it the addition of carnivore or is it the removal of something else that was actually like you, because when you remove the previous diet, you're not really
yeah,
removing anything. You're replacing it with something else, and that would
mm,
be the absence of something. Is the addition of the absence of something actually causing you to have an issue?
yeah,
That yeah, like oxalate dumping would be a perfect example because
exactly.
if you perform a study, let's say you perform a study on like 90,000 people that go carnivore, and you see that like 50% of them develop symptoms that are directly traced to oxalate dumping. Someone might come along and say, oh, that means this is a reason you shouldn't go carnivore.
Yeah,
Well,
yeah,
but wait a minute, because that assumes that it's the fault of carnivore for causing the problem, when in reality, it could have been the fact that you weren't carnivore. The problem is that you weren't carnivore and then you did it.
it's
And
part of
then,
the
like,
cure.
yeah,
Just got
like,
to go through it.
yeah, like, because that even just goes to show that even if there is a causal relationship between something, that doesn't mean that there isn't nuance there to be discussed. Like, okay, yeah, let's say that you could prove unequivocally that that was a cause and effect relationship between the adoption of carnivore and oxalate dumping. That doesn't mean to not go carnivore, because
Mm,
it doesn't mean that. That means, oh, so this is what happens when you go carnivore if you haven't been doing it for however long. You
yeah,
grew up eating a completely different diet. You've gotten a bunch of problems that result from that. Stuff
mm,
like that. And so when it comes to weight loss, all those things need to be considered. Like when people are trying to lose fat on carnivore and they are being told, oh, well, protein is the enemy and not fat. You want to eat a lot of fat and not protein. Or some people are told the exact opposite. You want to eat a lot of protein but not a lot of fat.
yeah,
Um,
yeah,
that's like the sort of Maria Emmerich approach. And I'm not trying to name names like pointing fingers. I'm just saying that's the traditional approach there. And then you've got people that are like saying that eating like I've known these people they eat sticks of butter every day
mm,
and they eat low protein and they're doing fine too. But
yeah,
I think the problem is assuming that there's a one size fits all in that respect, especially when you're dealing with people that, in terms of their phenotype, are completely, we're way I mean, we're way off the grid with our genes and the way they express themselves. Because typically in traditional genomes, or in every other genome, there's slight differences in phenotype, but they're pretty much the exact same because they're under the same environmental conditions. And that includes the foods that they eat and the foods they have available to them.
yeah,
Humans now, our phenotype is such a stark deviation away from what other animals are going to exhibit in terms of their phenotype, that giving a one size fits all for that is a little dogmatic and
mm,
irresponsible, I think. And also,
yeah,
this is why I've also said that you can actually still use carbohydrates as a drug transiently when you're transitioning someone, or if they're dealing with things that seem to be like irreversible metabolic damage. I saw someone had liver damage that seemed to affect the rate at which they could produce glucose by their own bodies. Well,
okay,
if that's the case, then you actually do have a requirement for exogenous glucose, or else
Yeah.
you're going to be hypoglycemic. So stuff like that, I think, can happen, and I think that the best way of approaching the situation is obviously, this is always the case with everything. It's trial and error. Like, okay, if you're struggling with fat loss, let's look at your macronutrient profile, like protein versus fat. Let's look at the frequency of the meals you're consuming. Let's look at the size of the meals you're consuming and how that equates in terms of a mass value. We don't really do calories, so
Yeah.
but like,
Right.
yeah, the mass of food that you're consuming and all that, and how that equates to what that is in protein, what that is in fat. So not just the ratio of fat to protein, but also the absolute values of all that, and the frequency, your activity level. Are you grounding? Are you not grounding? What's your sleep
Mm.
looking like? Do you wear a continuous glucose monitor? Because maybe that can give us an idea as I don't know. I've dealt with even people personally that have said that, like, whenever they initially went carnivore or something, they were waking up in the middle of the night, like, wide awake. I
Yeah.
actually had this happen one time whenever I was attempting my first, like, 48-hour fast.
Okay.
My body wasn't used to it, it seems, and I didn't have
Mm.
like any muscle on my body at the time. So I've gained about 10 pounds of muscle just from eating carnivore over the course of 2 years, and I didn't do
Yeah.
anything to gain that. So before that though, that wasn't the case, and I think that may have had some influence over like glucose production or something. I just wasn't used to 48 hours. I woke up in the middle of the night and I was wide awake. It was kind of,
Yeah.
I was like, this is odd. It was unsettling because I was like,
Yeah.
I slept for 2 hours, woke up at 1 in the morning, and I was like, this is not right. So I actually went and ate. That was at the 31-hour mark. Then afterwards, that didn't happen anymore. I was able to go 48 hours, and there wasn't really a problem. So stuff like that, like introductory stuff, that's something to consider. It doesn't mean to never do something like that. It just means, slow and steady sort of wins the race. And then, yeah, again, since you specifically asked about fat loss, I think it's a matter of adjusting ratios of protein to fat.
Yeah.
Um, it's also potentially, if someone has satiety signals that are sort of disturbed,
Mm.
it's about um, getting the mass of food either up or down. So that's another situation. Does it look like their metabolism is too slow and that's why they're not losing fat, or does it look like they're eating way too much
Mm.
because they're
Yeah.
eating butter, or they're eating sweeteners maybe, or a lot of dairy, for example, and
Yeah.
they're storing fat that way? Because that is another problem. I think this is one of the reasons why the sugar diet was so successful in terms of short-term
Of
weight
that.
loss for some people.
Yeah.
Yeah, 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 yeah.
Yeah.
Because I think that those people, when they were stalling, I think one of the reasons they were stalling was because their insulin was actually too low. And if you get too low of insulin, your metabolic rate's really slow.
Yeah.
So,
Could have had a crash, wouldn't they?
yeah,
From going so high all the way down to below where it should be.
yeah, yeah. And I think that had to go, that came down to maybe too low of a protein bolus, or too low of just a food intake in general. I know that if people are struggling with too little of an amount of food, they're getting down too little food. Um, they are oftentimes, I've dealt with this myself. If they're eating ground beef, like minced beef,
Yeah. Yeah.
they it's I can get about double the amount of food down if I'm not eating ground beef
Oh.
than yeah, than if I am eating ground beef.
Yeah.
My stomach gets full real quickly that way. If I'm eating steak, totally different story. I can get a lot more down, at least 50% more down.
Right.
Um,
Okay.
And if you think about it in terms of what we were actually eating historically, when we killed a cow, we weren't taking all of the pieces of a cow, the scrap pieces of a cow, and then grinding
Yeah.
it up into it. Like,
No.
it's
Right.
not, yeah, it's not to say that you shouldn't be eating ground beef, but it is to say that if you seem to be eating too little of an amount of food and you just cannot stomach more after eating ground beef or something, well, then you might consider eating a different cut of meat,
Yeah.
because
That makes
that
sense.
that has happened with, and it's not just me. Once I said it once because I was like, you know what? Maybe other people are dealing with the situation too. I'll say it and see what response I get. Almost every single person invariably has said, "Oh yeah, I didn't even think about that. That happens
Mm.
to me all the time whenever I eat ground beef. I eat way less food."
Yeah, because like, you take how much there is there, and that you don't really think, do you, that that might be a possibility. But yeah, like
Hmm.
you said, you're not going to be out in the wild with like one of those machines that you see at the butcher.
Yeah, like a meat grinder or something.
Meat
Yeah, yeah.
grinder, yeah, yeah. They've only had them for a few hundred years or whatever it might have been, but yeah.
Yeah, yeah, exactly, exactly. And I did well, yeah, and then I thought about that and I was like, "Oh, yeah, no, that makes sense. Like we didn't have ground beef. Like you look at ground beef and it doesn't sometimes you forget that it's even ground in the first place. Like it's a processed form of cow.
Yeah,
And
yeah.
then you remember you're like, "Oh, yeah, that's not you didn't take that from a cow, like a piece of it. Like that's a multiple
Mm.
pieces ground up into one log, so to speak." So, steaks I think are always your best option, and you can get cheap steaks too. I mean, it depends on where you are. It depends on where you are. I know that. I mean, you're in the UK and things are different in that respect. Meat is quite a bit more expensive depending on where you go.
Yeah.
Um, yeah, I actually it's funny because I talk most of the people I talk to are from the UK. It's
What,
very
really?
yes,
Yeah,
yes.
okay.
I was before I got on this call, I was talking to someone from the UK. So yeah,
Okay.
yeah, yeah. So I know a bit. I know a bit about your situation with that, but
Mm.
it just depends on where you are. But if you can't, I mean, ground beef is still an option. It's something to consider if you think you are eating too little, and that could also be influencing losing fat. If your metabolic rate is too low, problem. If you're eating way too much beyond what your metabolic requirements are,
Mm.
also a problem. So it's a balancing act in that respect, in terms of the amount you're consuming, as well as the ratios of fat to protein, I think. And if people are having a problem with eating too much food, dairy, big culprit there,
Yeah, definitely. Yeah.
really big culprit. And by the way, that includes butter, because I don't know what's
Yeah.
going on. I don't know what the thing is with butter, like what the compound is, but I can't eat like if there was a brick of tallow, I couldn't like eat tallow the way that I can eat
No.
butter.
No, yeah, no, I can't even bring myself to think about doing it, but
Exactly.
yeah.
I don't know what the compound is in butter because there's no lactose in it. There's none of those there's none of the casein proteins really, but I think that there's still like vestigial remnant parts of it that maybe are still influencing that because I mean, I don't know what it is, but the anyway, it includes butter. Also,
Mm.
yes, of course, sweeteners and I think those are the biggest things. I don't really think anyone's overeating on fish. I don't really think anyone's overeating. I mean, unless you're talking about you're getting too much protein from fish because it's not balanced out with fat. That could be a possibility.
Yeah,
Um,
might be able to get that from salmon because the salmon well, it must be with every salmon like cut of it that you get, I think, in like 220 grams of the salmon that I usually eat. Maybe it's 50 grams of protein, but only about 20 grams of fat.
right.
That's
Yeah.
that's the sort of ratio it is. So if you
Yeah.
need to get it to a 1-to-1 ratio, it's got to be salmon and something else.
Mm-hmm.
Maybe if you cook it in tallow or something to maybe bump
Yeah.
it up a bit, the fat.
Yeah. 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 So I mean, it is a possibility to overeat on fish because now that I'm thinking about it, I mean, you talk about shrimp, for example. If someone's just to have shrimp,
Oh yeah, that's no fat at all.
no fat at all, and you know how much
No,
protein you can get down with shrimp. Then, like you can
a
imagine
lot.
a lot of it, a
Yeah.
lot. So that also matters. I mean, this is why I say, I mean, the best approximation to a species appropriate diet for humans would be ruminant meat, because
Yeah, of course.
I mean, it doesn't have to be the specific type of ruminant animal we were eating historically, because most ruminant animals, in terms of their composition, that's why I say approximation. They're
Mm.
approximately the same across the board. When you get to things like fish, that's a different story.
Yeah, yeah.
So then, yeah. So I mean, it's always you want to be careful with that one too. I think the one thing not that you don't have to be as careful with is probably eggs. Eggs are a pretty good mix, and I don't really see too many people overeating eggs. In fact,
Yeah.
I mean, I can tell you right now with me, I always find myself thinking about eggs as really appetizing, and then I go and eat them, and then I don't want to eat more than like two, and then I'm wanting to eat meat again. Like I don't
So
even really.
I'm pretty bad with eggs. Like I'll eat. I could eat like 8 eggs in a sitting.
Really, really.
Yeah. So
Okay.
in about like eight. So I do like 10 grams of butter per egg. So I might make like 2 4 egg omelets.
Okay. Yeah.
And
Yeah. Yeah. Well,
yeah.
okay. Okay. So, what do you think is the reason for that? tendency with eggs as opposed to meat? Do you have any idea or?
I don't know. It's eggs has always been my thing, you know. Like it's always been like the sort of thing that I like to eat. But
Mhm.
with ground beef, though, I just find it really convenient to like just cook, take to work, heat it
Yeah,
up,
yeah,
eat it, you're done.
yeah, yeah,
So,
yeah, yeah,
you
yeah.
know, it's yeah. At the moment, I'm not eating many eggs at all. Just as
Okay.
yeah, just because I'm trying to like I'm on a bit of like a cut at the moment, just trying to like reduce my body fat by like a couple of percent, if that makes sense. Just
Hmm.
trying to yeah, and that obviously means like taking in the amount of the amount of food that's got to go down, and just got to be more careful. But
Yeah,
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 that means not so many eggs at the moment.
yeah. What form do you eat them in?
Scrambled.
Okay, yes, so do I. So
Yeah,
do I. I typically do
yeah.
that. Do you eat once a day or do you eat twice a day?
So I'm eating twice a day at the moment.
Okay.
Um, but it used to be three, only two, like when I was wanting to like, put on more muscle, I was, it's like the only way I'm going to get this food in is if I do eat breakfast, lunch, and dinner,
Mm-hmm.
by just adding the breakfast and then I've got it all in then. And I think Anthony Shafee said at one point there's not so much of a need to fast on carnivore because your insulin's kept low anyway.
Yeah.
Therefore, you don't have as much of a need as someone who eats carbs.
Yeah,
Yeah,
yeah, yeah. No, I tend to agree with that too. It also, I will say it does depend on who you are because there's some people that I did a video a long time ago where I said that actually you can get into deeper ketosis when you eat a meal if you're eating a carnivorous meal.
yeah,
Um, but some people will get out of ketosis. It's completely arbitrary, it seems. I
yeah,
mean, it's very interesting. But what that does mean is for the people that are bumped out of ketosis, if they eat 3 meals a day, that might be a different issue. But it might actually be an issue for them, as
yeah,
opposed to someone else that might actually get, into deeper ketosis. I mean, they're really just using a lot of that food to create more heat. Then you get more thermogenesis. You can actually start, like radiating heat the more you eat. So it's
mm,
it's it's just people respond differently to food, and I think of course it does depend on what the food is made up of as well. Like as much as it might be zero carb, what are the
yeah,
types of foods you're eating and what ratios and all that. That still plays a role, I think, and what else you're doing too, as all that stuff is all as all that stuff tends to influence the results of certain behaviors. So,
yeah.
um, yeah, but okay, so 2 meals a day, and you don't really track like do you track how much you're eating? I know
I
that you said that now that you're doing this sort of protocol, you're focusing more on it, but typically,
Yeah, typically I do just more
okay,
because just to track like the amount of like the macros. So just making sure I'm eating enough protein,
okay,
getting the fat where I believe it should be, that sort of thing.
mm-hmm.
Just using like the typical tools like MyFitnessPal that they all focus on calories, don't they? And like you think
Mm-hmm.
I might use it as like I might use calories as like a number to aim for, knowing that it's meaningless. It's just if I reach that number, I've eaten enough to reach my requirement of protein and fat to meet the goals that it is that I need to do at that time.
I think the calorie number is more of a problem in the context of an extremely varied diet. So I'm
Yeah,
not saying that even on I'm not saying that on a carnivore diet you can therefore like trust calories completely, right?
no,
But calories are attempted to be they're designed to be sort of a proxy measure for how much mass you are consuming because the idea is
mm,
that well, we're thermodynamic systems, you eat a food, it's going to create calories. That's why we release calories in the form of body heat, blah, blah, blah. There's an
yeah,
element of truth. There's an element of truth there, but it's just not the full picture. I think the main problem is, I'll give you an example. People, you see all these recipes that are like online where they're like, they make huge bowls of food, but they'll say, look at how many calories this is.
yeah,
Like
yeah,
400 calories.
yeah,
Yeah, that's but that's a problem because that means that whenever you're actually looking at the calorie number, you may very well be able to drop your calories and eat way more food. Well,
Mm,
then you're not really doing yourself a favor. Like they pretend like that's a good thing, but it's like, well, that would only be a good thing if the whole philosophy was correct. Like, no, your body doesn't even recognize the calorie number. It recognizes
no.
what is the mass you're consuming, how much of that mass is actually absorbed, and how is that mass influencing your hormonal balance. Those are the three factors that actually
Mm,
matter the most. So you can
yeah.
imagine if you're eating a varied diet, like an extremely varied diet, the calorie number is way more noisy. If you're eating only like two types of food a day,
Exactly.
calories have more utility. Again, I still think that mass is a better unit to use, but
Yeah.
I understand what you're saying because, yeah, there's a constant there that makes the calorie number more reflective of sort of reality than it would
Yeah.
in a varied context. It still does have a very, very strong confounding factor, even in that context, which is the fat uh, calorie amount, which is 9 calories per gram versus
Yeah.
4 calories per gram for protein.
That's right.
You, if you eat like more butter that day, you could actually have eaten a lot less, but you'll have hit
Yeah.
that calorie number, and it'll be like, oh, well, then I ate enough. So there's still some noise there, but I'm just saying, I think it is less problematic in the context of a more static diet and
Yeah.
strict diet than, yeah. So that's what I'll comment on that. But anyway, yeah, okay. So you clearly, I mean, you're very fastidious with your diet. You clearly care about what you're eating and also how much you're eating and the ratios and all that stuff. You understand your body better than other people. So
Yeah.
better than anyone else. So as long as you're not having any problems with that, then the last thing I'll ask you is what makes you want to track the fat and the protein content and the absolute mass of food you're consuming in a day as opposed to just your overall appetite? Do you have problems with like appetite regulation or is that
No, no. I mean, I find that I almost do it through habit, to be honest. It's what I've
mm,
always done, and it's kind of what's worked. And I do find, like, for example, like if I have, 500 grams of ground beef for my lunch, I know then that I'm going to be satiated all the way up to say seven
mm,
in the evening when I have
yeah,
my dinner, and
yeah,
then that kind of regulates how often I eat, and then it almost guarantees that I'm going to be getting in enough food for my requirements for that day. And it's like simplicity is exactly what works just for me. Like other people, they'll like to, make all the carnivore bread and all of that sort of thing. And it's kind of like,
yeah, yeah, yeah,
it's
yeah,
like grab back, what might be carbs. And it's like, oh, but it's still bread and like, but it's carnivore. And yeah, but
yeah.
it's a good option, but yeah, just simplicity is key, and like it's that's just the way it works for me.
Yeah, yeah, definitely. Yeah. I used to try and track all my numbers and all that stuff because it was for a completely different reason. I actually think I'm always told by my fiance, by other people as well, that they think I'm on the spectrum a bit because of the way that I think.
Okay.
Um, because I am like really, really, really meticulous. I was tracking those numbers just to know exactly how much I ate in a day, not because I really like was concerned about it, but because
Yeah.
any form of chaos, like anything that I don't know, I want to crack down on. Like,
Okay.
if anyone wants to know why my passion for learning the things that I learn and
Mm,
have learned over the course of years is to the degree that it is, that's where that comes from. Is just if
yeah.
I don't know something, I refuse to accept that, and it bleeds into things that are completely trivial. Like, okay, how many grams of protein did I eat to the number? How much fat did I eat to the number? Cholesterol, sodium, this and that. I was doing that, but it
Yeah.
became actually it was unsustainable. So a lot of people will think, like this is where the claim comes from that if you track your food all the time, it's like really unsustainable because how could it took me forever to even write it all down and then like the calculations that I had to do and like the
Yeah.
the
Yeah.
the considerations as to like the things that I didn't track because they were just in passing. I like took a bite of something. I was like,
Yeah. Oh, you
like
you
it's
go that far with you.
Yeah. And so I typically say that the first thing to do is to trust your appetite. If
Mm,
you find that your appetite isn't to be trusted because, for example, your hunger signaling, your satiety signaling seems to be disrupted because of past behaviors, this can happen with people that had eating disorders. So
yeah,
bulimia, anorexia, or like binge eating kind of goes along with bulimia.
yeah,
Um,
yeah.
those people seem to have disrupted hunger signals and also a different relationship with food anyway, which also influences hunger signals. Because if they
Sure.
feel like, they can actually gaslight themselves into thinking they're not hungry. So,
Yeah,
you know,
yeah,
then it'll become like, okay, so let's do these based on these general metrics. Let's try and get this much protein in, this much fat in, because right now we can't seem to trust your appetite. Like that, again, I say this with as much humility as possible because I want to be very clear that I've never taken on any clients before. That
yeah.
this is more. People have more experience with this than I do. So of course, like Coach Stephen Thomas and Coach Richard Smith, I
Oh
mention
yeah,
them all
yeah,
the time. Yeah.
yeah, yeah.
They
Good.
they're good people to get a hold of because they've taken on clients for a long time. So
Mm,
I'd be curious to hear what they have to say about what I've been saying. Because typically, I don't really, I don't know. I haven't talked to them too much about what they deal with their clientele. So I'd be interested to hear about, how common, what protocols they sort of implement with people like that have previous eating disorders or bad
yeah,
eating habits or something like that.
that would
I
be.
would think that they would have general criteria that must be met at that point. Like,
Yeah,
okay, let's try this out and see what happens with that. But
yeah. They must have like a specific way that they deal with those kind of people because
yeah,
they are special cases and they need to be dealt with quite carefully.
mm-hmm.
So so that they do genuinely overcome and sort of have a positive relationship with food again, which is essential for everyone, but especially for them.
Yeah, definitely, for sure. Yeah,
Yeah.
yeah. All right. Well, was that all your questions? I mean, I'm willing to take some more. I do have some time, but
Okay. There was just based on one of the your previous videos actually. Um, I can't remember who it was with. I think it was with what's his name? Ascending Aesthetics. Is that? I think that's his name on Facebook.
ascending Stoics. Nathan Erbauer.
Nathan, that's it. Yeah.
Yes.
You discussed with him about egg whites and the anti-nutrients in
Uh
egg
huh.
whites. Yeah.
Yeah.
Was it him you spoke to him about that?
Uh huh.
Thought
Yeah.
it was. Yeah. So, but this is before I was carnivore, right? I used to do this shake, and I've had questions already come up on the Facebook groups that I'm now like like labeled as a an expert on.
Mm-hmm.
There was this one person who said, "Does anyone know of like an easy to grab shake that I can have for breakfast?" And like straight away, you think you want me to name something you can get from a shop. Like
Yeah.
nothing.
Yep. Yeah. No.
Yeah.
No. No.
Yeah. So I the first thing I thought of was this shake I made, and as part of it, I put in four raw eggs and milk along with other stuff to like give it some flavor, like a banana, some whey protein stuff that
Yeah.
I wouldn't have now, but there you go. Um, but yeah, it just makes me wonder, like those who do shakes like that, who use things like raw eggs in to make a shake quick and easy like that. What kind of, I guess, damage in the kind of medium to long term might that be doing, if anything?
It's hard to say. I mean, what I will say is the main problems with those anti-nutrients is that they bind to biotin.
Yeah,
Like Avidin, for example. Yeah, the Avidin will bind to biotin like glue. Like it's almost like a one-to-one kind of thing. I mean,
right.
it's it's something to watch out for considering that red meat already has very little absolute amounts of biotin
Yeah,
because
so
that
you,
goes for all B vitamins and vitamin C and all that. So
yeah, yeah,
it's hard to say the exact ramifications. What I will say is that in terms of, well, I mean, there's already it's already sort of straightforward. I think that if it's that much of a problem, you shouldn't really be eating raw egg whites. But what I will say as a final sort of thing is, if it's not giving you any symptoms, then
Yeah.
perhaps keep doing it. Like there's no identifiable
Sure.
disease process. There's no, like, nothing's going on. Then go ahead, keep eating the raw eggs if they're convenient and they help you with your overall diet regimen.
Mm.
Um, I have a friend who's been doing this for years now. Exactly what you just said, actually.
Yeah.
For and actually, except instead of four, I'm pretty sure it's been 8 or 9
Wow.
eggs. Yeah, yeah, yeah. And I remember when that video uploaded, it was like the hidden risks of egg whites.
Yeah.
Uh, he got an email because he subscribed to my Patreon, and he messaged me immediately and said,
Mm.
"What are you talking about? Hidden risks of egg whites?" And I had to tell him, I was like,
Yeah.
"Oh, you don't know? Yeah, I forgot.
Huh.
You, for years you've been downing raw eggs."
Yeah.
And but he's an example of someone that hasn't had any problems. Like he hasn't had any symptoms.
Yeah.
So it's one of those things where, okay, so we know that there's anti-nutrients in there. We know that that should probably be avoided considering we weren't really eating lots of raw egg whites throughout history. But who is to actually say that that will necessarily result in nutrient deficiencies?
Yeah. Yeah. Because it's you want to stop the symptoms before they arise, don't you?
Yeah,
So
yeah,
even though you don't have symptoms, something might be brewing. Do you know what I mean?
yeah.
Underneath.
Which is that's why I say, okay, I don't, if there's a way that you can get around not having raw egg whites, then maybe we can, let's consider that, right?
Do it.
Like,
Yeah.
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 But if you have no other choice for some reason,
Sure.
then okay, well, just here, just be aware of, I suppose the risks again, because you can't really guarantee it's a risk for them, but the
Yeah.
ostensible risks there, and then just as long as you're aware of that, go along with it. And a lot of people will hear that, and sometimes when you say that, they'll almost conflate that with fear mongering, like you're trying to scare them into a position when it's like, no, 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 I just want to make sure you're aware that this
Yeah.
can
Yeah.
happen. Like,
That's just a fact.
yeah, like I'm not saying it will. I just want to, if it's a possibility, here's the possibility. I mean, it's
Yeah.
like it's the same reason that pharmaceutical advertisements in the U.S. and New Zealand, that those are the only countries that have the ads run, will be like, oh, well, ask your doctor about this drug because side effects may include, and then they list a huge list of them. The difference is
Mm.
that eggs are not going to cause, blood vomiting and a bunch
Yeah.
of other horrible problems that are associated with the taking of pharmaceutical drugs. So,
Exactly. Yeah.
yeah. But it's the same reason, just on a microcosmic scale, because the ramifications aren't as uh, dismal as those ones are. So,
Mm.
yeah,
Cool.
yeah.
Yeah, I think that was the last of my questions actually. But yeah, no, that was really good, Eddie. Thanks.
Yeah, yeah, awesome. Yeah, no, this was fun. I always like doing it. Like I said before we got the call started, it's always intellectually stimulating. I like talking about the concepts, and I like getting it out there. I mean, I'm as philanthropic as possible with the information that I provide. So,
Yeah.
um, but yeah, no, this is fun. If you have any more questions regarding, the biochemistry type stuff, the certain elements of cardiovascular pathophysiology, because I mean, I'm not fully well versed in that. My expertise, quote unquote, is all over the place. So,
Yeah.
with the stuff that I talked about in the program and some things to talk about on the in my regular public material, you can schedule another call since you're a certified coach and all that, and we can get a date scheduled and do another one, if you're
Yeah.
into that. So
Yeah. No,
yeah,
sounds good. Cool.
awesome. All
Great.
right.
All right.
Well, it was good talking to you, and I'll talk to you soon, perhaps.
Yeah, definitely. Yeah. Yeah. Cheers, Eddie. Thanks.
Yeah, yeah, no
All
problem.
right.
See ya.
Thanks. Bye.